In this AI fundamentals video, we're going to be going over the basics of a neural network, and that's this idea of a perceptron, which is essentially a mathematical formula that allows us to sort two things into different categories. We can create an algorithm that can then identify patterns and then choose between A and B. The reason this is the basis of a neural network is that a neural network is a combination of hundreds, thousands, millions of perceptrons to create a final end result. So this is essentially the first tiny part of that will allow us to then build out neural networks and then to build out AI engines. So we're going to run through this step by step to actually understand the perceptron and how it is generated so we can understand the concept really well. This is off my website, csvisualizations.com. You can go ahead and take a look at the link in the description below. Essentially, we're going to be trying to take two inputs, humidity and temperature, to guess whether it's going to be sunny or rainy. In this, we're going to take these inputs with a bias. We're going to have it print out a mathematical model. If it's a negative number, it's going to be sunny. If it's a positive number, it's going to be rainy. So with this, we're trying to go through this algorithm with a set of known data, which is right here. The first day is 82% humidity and 16 degrees Celsius. The second day is 77% humidity and 18 degrees Celsius. Both of these resulted in rains. And we're going to be running through a series of data that looks like this over here on the graph. And we're going to be trying to predict what exactly a future day might look like if given these inputs. So to begin this process, we essentially take our humidity and temperature and we put them in the middle of the graph at 50% each. These are what our inputs are. We're going to normalize all data. That means that weather is going to be put into between 0 and 1. So humidity is not going to be 55%, it's going to be 0 to 1. That one's actually pretty easy to convert. We're essentially going to just take that 1 is 100% humidity, 0 is 0% humidity. For the Celsius, we're doing it slightly different because we don't want to run through 100 degrees of Celsius, so it's a slightly smaller one between 0 and about 33 degrees Celsius. So 33 is a 1, and then 0 would be a 0. Once these are normalized, it allows us to fit the data a lot better. We're then going to use those over on the left side here as our humidity and temperature. We're going to assign random weights to it. This is how influential each of these inputs are. So is humidity more of a determining factor, or is temperature more of a determining factor? Our algorithm is going to make guesses and learn based off of the iterations to figure out which one is weighted a little bit more. And finally, we have this idea of a bias. This is just a way to skew the graph up and down so we can actually move the line to better fit what our data is telling us. At the end, we run it through our formula. We get a negative value, meaning it'll be sunny, or a positive value, meaning it'll be rainy. We're going to essentially run through epochs or different sort of iterations of this, and each time we're going to be learning. What we're utilizing here as well is a decaying learning rate. What that means is as we start, there's going to be wild swings, but then as we hone in on our answer, the swings are going to get less and less and less until we're locked in and we're not getting any incorrect answers. So we can now run through these steps. The first one, what we're going to do is we're just going to set up the basics. We're just going to set up the neural network, what our weights are and our biases are. It essentially generates this first decision boundary. Now, anything above it should be sunny and anything below it should be rainy. This dotted line is just a quick mathematical algorithm to say this is kind of where we want to aim, but it's never going to end there perfectly because if we could just calculate that each time we would. We're trying to have it learn it itself, which will come out slightly different each time. So the first one we grab is it's essentially this input data of a humidity of 82 and then a temperature of 16 degrees, normalized to 0.4 and to 0.8. It's actually, in this category, it's rain, but because it's above the line, our algorithm predicted it to be sunny. The algorithm was wrong, so it's now going to go through its learning loop, which is essentially going to be taking this weight. The new weight's going to equal the old plus the learning rate times the error times the input. It's a long algorithm that just basically means we're going to adjust all of our weights just a little bit to try to make sure that we're a little more accurate here. You can see that our weights have changed. This is now 0.27, this is now negative 0.48, and our bias has changed a little bit as well. We run through another example. We're still wrong because even though we move this line up, we are not in the exact right place. It's still saying it's going to be sunny when it's not. So we move it back up again. Our weights have changed once again. Our weight is now a 0.031. We've gone through 0.272 up to 0.307. And then our temperature has gone from 0.477 to now 0.456 negative. Our bias has moved a tiny bit as well. We run through it one more time. Those two were accurate. This last one is accurate. We guessed correctly, so we don't need to go through another learning iteration because we've already guessed correctly. So we keep running through our points We see another wrong one, we swing the line back again. Our weights have changed, our bias has changed. Now, here's the issue. We swung it too far outside. So, although all of the rain will now work, and a few of the sunnies will work, our next one right here is now wrong. Because now we're guessing with our 52% humidity, 22 degrees Celsius, and we're saying, hey, this should be, since it's below the line, it should be rainy, but it's not. It is sunny. So we run through an iteration learning loop on that one. It swings a little bit farther back down to the bottom, and this is why a decaying rate is important, because otherwise we might just oscillate back and forth indefinitely. But with this, we can actually keep slowly oscillating closer to whatever should be a true value. We run through another one, get to our next one that is wrong, we swing it back again, run through lots of correct ones, another one that's wrong, we swing it down again. And like I said, we're oscillating a little bit here, but because of that decaying rate, instead of it swinging above this one again, it actually fits our line pretty closely. We then go through a final pass where we actually just run through a bunch of our points just to make sure that there's no more learning needed, and then we kind of end it there. Now, this is a very nice, easy to look at graph. If there are points that actually go on each side of it, we don't have to say that it needs to be perfect every time. We can actually set a threshold. It should be 90% correct, and then we're going to call it there, etc., etc. But we have our final decision here. What we have is our humidity and temperature. Our weights are now at a positive 33 and negative 45 with a bias of 0.05. Essentially, this is our algorithm now to predict rainy or sunny weather. Why this is the basis of AI is because this perceptron could predict weather, and then another one beneath it could predict clouds. And you could then combine both of those to predict rain forecast, we could predict wind from it, and we can keep making that more and more complex over time. And instead of us creating this perfectly straight line, we can add curves to the line, S's, we can create little carve outs. It gets more and more complex. And then if you get up to the millions and millions of these little neurons, that's when you start creating really powerful prediction engines. Thanks for joining me for this small fundamental of AI, this idea of a perceptron. If you like this visualization, go to csvisualizations.com, and there's lots of them on there. I'm adding more to them. And then if you like this video, go ahead and hit that subscribe button. I'm going to be covering all the basics of AI fundamentals, and we're going to be slowly building our own algorithms by the end of it. So hit that subscribe so you don't miss any of those videos. Till next time, everyone, see ya.